Hello, my name is Marilyn Sanchez, and today we will be working through Chapter 3, Problem 81. The question goes, 3 balls are launched simultaneously as in the figure. The red ball is launched at an initial velocity directed at an angle theta above the horizontal. The blue ball is launched vertically with a speed of 10.4 meters per second, and the yellow ball is launched horizontally with a speed of 4.40 meters per second. The blue and red balls reach identical maximum heights and return to the ground at the same time, and the red ball returns to the ground to meet the yellow ball at the same place along the horizontal. Find A, the launch speed of the initial velocity, and B, the launch angle theta for the red ball. Now, since the blue ball and the red ball reach identical maximum heights, we can acknowledge the fact that the vertical velocity of the blue ball is equal to that of the red ball. This means that they are both 10.4 meters per second. The same can be noted with the red and yellow ball. We were told that the red ball lands in the same place as the yellow ball, meaning their horizontal velocities are both equal to 4.40 meters per second. Now, with these values known, we can set these up into the Pythagorean theorem to solve for the launch speed. Now, why might the Pythagorean theorem work? Well, in this situation, think of it as of a right triangle. We know both the vertical and the horizontal values, and we just need to find the hypotenuse, which is in this situation, the speed that we're looking for. Meaning, we can plug these in to find the launch speed, v0. Now, we would put the initial velocity of the horizontal squared plus the initial velocity of the vertical squared, all square rooting that in order to find the launch speed. As I finish writing this up and afterwards plugging it into my calculator, you should get an answer of 11.29 meters per second. But we're not really done yet in this situation. We are also asked to find the launch angle theta for the red ball. We need to find the angle theta, but how can we do that? Now, this requires a bit of thinking back into what we were previously taught, and from that we can gather that we can solve for angle theta by taking the inverse tangent. We do this by taking the inverse tangent of the velocity of the y over the velocity of the x, which we were given earlier. In order to get the final answer for problem B, we would just plug in what we know into this equation. So we take the inverse tangent of 10.4 meters per second over 4.40 meters per second. And after plugging this into your calculator, you should get the degree of 67.1. Well, that is it for today's video tutorial. I hope this helped strengthen your knowledge on this material, or at least helped you better understand this. I know it's hard. It definitely helps to watch someone go through the problem, and it definitely really helped me in the long run. So yeah, thank you so much for watching, and I hope you have a great rest of your day or night, whatever time you're watching this video.